Measuring instrument, measuring instrument in physics. If you get to your physics textbook, you're going to find out that there are a lot of topics down there or in that textbook, but you're going to find out that they have a topic known as measurement and unit. That's the first topic you're going to find in most of the physics textbooks, if not all. But because physics is a science that deals with measurement and accuracy of physical quantity and exactitude of unit. I take it again. Physics is a science that deals with the measurement and accuracy of physical quantity with exactitude of unit. You notice that I use the word unit because it is unit that gives you the meaning of the stuff or the quantity you are measuring, the physical quantity. Physical quantities are the distance, the mass, the temperature, the electricity, the force, momentum, pressure, and so on. A lot. Now, for you to be able to know what we are talking about, there must be units. For instance, if someone asks you what's the temperature of your body, you cannot say the temperature of my body is 37 temperature. That's wrong. We won't understand what you're saying, but when we say 37 degrees Celsius, it makes a sense to us. We know you're talking about temperature. Without even talking about temperature, saying temperature 37 degrees Celsius, we already know that you're talking about temperature. If I say the distance from the school to your house, you see, you will say 10 meters. That meter that you put there gives you the meaning that you're talking about distance. But if I say distance from here to my house is 10, it doesn't make sense to us. But the meter gives it its accurate sense. Now, we're looking at measuring instruments in physics. There are a lot of them. This is just few that we brought up. There are a lot of them. We're looking at meter, vernier caliper, micro screw gauge, micrometer, the spring balance, the beam balance, the ammeter, the galvanometer, and the voltmeter. Alright? Now, the concept is that the meter rule is used to measure distance of a field. Okay? It's used to measure the distance of a field. It's a sort of a ruler, kind of a ruler. But this kind of sort of a ruler is not just a small ruler, it's a long one. If you get to the physics lab, you'll see that a metal rule is very long, but it looks like a ruler. The first time I saw it, I said, what type of a tall ruler is this? It's not a ruler. My teacher told me that that is a metal rule, okay? Looks like a ruler, but it's very, very, very much long, depending on the calibration of that metal rule. So we have the first one to look at is the metal rule. Now, this metal rule is being calibrated in millimeter and also in centimeter. It's calibrated in millimeter and centimeter. Now, the calibration of this metal rule in millimeter has a reading accuracy. And the reading accuracy of this calibration, if it is a meter, if the metal rule is a meter, in millimeter is 1 millimeter. And if it is a centimeter, it is 0.1 centimeter. So you can know that the reading accuracy of the metal rule, while doing your calculation, if your question is given to you in millimeter, the reading accuracy to use is 1 meter. But if your question is given to you in centimeter, the reading accuracy to use is 0.1 centimeter. Meanwhile, there are questions, those that are writing UTME exam, JAMB exam in West Africa, Nigeria, you'll find out that they can ask you, what is the reading accuracy of a metal rule in meters? Well, the reading accuracy of metal rule in meters, over there, check it, that is 1 millimeter. In millimeters, sorry. And when they ask you, what's the reading accuracy of metal rule in centimeter? Reading accuracy is 0.1 centimeter. Meanwhile, if you are asked a question that the least possible measuring accuracy of metal rule is what? Now that is tricky or trickish. Well, we are doing physics, not English. When we get to English, we know which one is tricky or trickish to write. Anyhow, so we're talking about which is the least possible estimate error value for a metal rule. Now, if I talk about the least possible estimate error, you'll find out that you're going to bring out this value and you divide it by 2. Bring out this value, divide it by 2. Then you divide by 2, that will give me 0.05, that is a centimeter. Alright, now you see that whenever you're measuring or having a least possible error or least possible measurement unit or accuracy, you should be having like 21.5 plus or minus 0.5 millimeter. Okay, or you have 22.5 plus or minus 0.05 centimeter. So if it is a centimeter or it is a millimeter. Meanwhile, if I ask the question, UTM, I saw the question in UTM, that's what is the least, get the question, not just the reading accuracy, the least possible reading accuracy for a metal rule. That is, they have an option. See what it is. They said, what is the least possible reading accuracy for metal rule? They put the option 1. They say 1 millimeter. Option B. They say 0.1 centimeter. Option C. They say 0.5 millimeter. Option D. They say 1 centimeter. Now you will say, but this option is correct. Yes, it's correct. The reading accuracy is correct. But they say the least possible error or the least possible inaccuracy of these metal rules. So the answer should be, the question is in millimeter. So sorry, everything is in millimeter. Everything is in millimeter. So if it is in millimeter, the right answer is this guy. Alright, 0.5. So that's on metal rule. The use of metal rule. Metal rule is used to measure the length, the distance of a field, maybe of a large area of land. Alright? So we're going to the next one. The next one is the vernier caliper. See? The vernier caliper. Well, I'm going to give you something to be useful to you, but let's just continue. Let me get a chart. And then the vernier caliper. Now, have you seen a vernier caliper before? Anyhow, if you go to a good secondary school, anyhow, you should have seen a vernier caliper. But let me give you a sketch of how it looks like. The vernier caliper looks somewhat like this. Looks like this. I'm not good in drawing, but we're going to manage it. We're going to manage whatever we have. Okay? Looks like this. Sorry. Alright, looks somewhat like this. Alright, it looks like this. Then it looks like this. Let's cut it from here. Then we have this. Alright, now this. And then we have something like this. And then back like this. Then we have something like this. So just manage what I'm doing. So this is how it looks like. Okay? Alright. Now this is how the stuff looks like. Now you're going to find out that the calibration will be there too. There will be a calibration there. Anyhow, I'm not an artist. Anyhow. So this is what I mean. Now, over here is where they call the internal diameter. Over here is the external diameter. Okay, internal external diameter. Here is the main scale. Over here is, here is the main scale. Then over here is the vernier scale. Alright, so this is how it looks like. Anyhow, we're going to be learning how to use these to calculate questions for exam type questions. Now, meanwhile, it has a reading accuracy. Let me ask, the question they will ask you is this. They will ask you which instrument is used to measure so material, okay, stuff. Now, the vernier caliper measures particularly, and it measures more accurately than the metal rule, okay? Get that? It measures more accurately than the metal rule. But meanwhile, it measures the diameter, okay, the internal diameter of a metal rule. It measures the internal and external diameter of a metal rule, the diameter of a metal rule, and then it also measures the internal and external diameter of a tube. Okay, you see that? And it also measures the diameter of a rod. Okay, you see that? It measures the internal diameter of a tube, external and internal, and also measures the diameter of a rod. So this is what we can use this vernier caliper to measure. It measures the thickness the thickness of this guy. It's not the diameter of the metal rule, sorry, it's the thickness of the metal rule. It measures the thickness of a metal rule. Meanwhile, let's go to reading accuracy. Reading accuracy for a metal rule, if it is in millimeter, is 0.1 millimeter. If it is in centimeter, it is 0.01 centimeter. Alright? So that's the measuring accuracy for the vernier caliper. Let's go to the micrometer screw gauge. But before we go to that, I want to give you some clue on how to remember the reading accuracy. So you don't need to cram so many things. There are so many things to know, so much. You don't need to cram. Alright, we have this diagram. I hope you can see that. Okay? Let me bring it back. So, is it visible? Is it visible? Alright, so we have this one is the instrument. We have in millimeter, the measurement in cm. Now, if it is a metal rule, let's use MR for metal rule, MR for metal rule. If it's a metal rule, the reading accuracy in millimeter is 1 millimeter. If it's in cm, it's 0.1 cm. Then we have the vernier caliper, CV. The reading accuracy is just see what you do, see what you do. Now, if it is a metal rule, the reading accuracy for a metal rule is 1 millimeter, in millimeter. If it is in cm, 0.1 cm. Now, just bring this guy, put him here. Now, it will become 0.1 millimeter. That is the measured accuracy for the vernier caliper in millimeter. But in cm, it's 0.001. Oh, sorry. 0.01 cm. Alright, you see what I'm doing? This one moves here, just add a 0 to it and then over there. Now if you have the micrometer screw gauge, Mr. CS, micrometer screw gauge, that's for micrometer screw gauge. So bring this guy here, this is 0.01 in millimeter, and then 0.00 cm, that's 0.001 cm. Now, this is the reading accuracy we'll be using to solve problem regard to this. Alright? So you need to know this reading accuracy. And for JAM, for UTN, they're going to test you on it. Now, what they will ask you is, what's the reading accuracy for vernier caliper in centimeter? You see that they want to know whether you know this. So you don't need to cram this. All you need to do is that metal rule, vernier caliper, and micro screw gauge. When you have gotten that, you know that metal rule is in 1 millimeter. You know that for the cm, it's 0.1 cm. And then just bring this 0.1 cm for the millimeter here, for the vernier caliper. And then you add another 0 for the cm over there. And then you bring that same value here for the millimeter for the micro screw gauge. You add another 0 over there, that's a cm, and then you're good. Now we're going to solve some problems. Alright? Now let's do the micro screw gauge and then we'll solve some problems. Alright? For the micro screw gauge, this guy measures more accurately than the vernier caliper. Well, the assignment for you is to go and find the difference between micro screw gauge and micrometer, if it does exist. Check whether it exists. Micro screw gauge and micrometer, find the difference between them. Spin balance, grain balance. Fine, drop the answer in the comment section. We're going to check it out. Ammeter, galvanometer, voltmeter, find the difference between them. Current, volt. But let's be between ammeter and galvanometer. We need the suggestion that not just be looking, you have to work, yeah, if you have time. Alright? So we want you to find the uses of all these instruments. So let's go to the micrometer screw gauge. Very quickly. Micrometer screw, you know what screw gauge. Alright. Now, over there, the diagram, if you have not seen that before, it looks like this. It looks like this. When you get to your laboratory tomorrow, you look for an object, you look for an instrument in physics that looks like what I'm drawing. Alright? I'm not saying that it is what I'm drawing. It looks like it. Okay? So it's not what I'm drawing. Alright? So we have something like this. So just like this. If I'm correct, yeah, like this. And then alright. So we have the calibration. We have something like this. And then we can have this to be 5. This will be 10. This will be 15. this could be 20. That's for instance. I'm not saying there's one. I'm not too good in drawing. So this is what we have. All right. So over here we call this the ratchet. Here we call this the vernier scale. Here we call this it's calibrated anyway, the mean scale. Here we call this the object that is being measured. The object here, call it the anvil. Alright? So that's what we have there. So we have over here is the spindle. Here is the thimble. Alright, so that is what we have. Here is the frame. So this is how the object looks like in your laboratory. So you can now know what micro screw gauge, a micrometer screw gauge is. Now, the instrument is used to measure more accurately than the vernier caliper. You see that now? It's even measured the thickness of a paper. Can you imagine a paper? The thickness of a paper can be measured using the micrometer screw gauge. Okay? So that's how accurately it can measure. So let's go to some questions. Tomorrow I love questions, okay? Let's go to some questions. And the real accuracy of micrometer screw gauge is on the board already. Over there, if it's a millimeter, 0.01 millimeter. If it's in centimeter, 0.001 centimeter. Then some of the textbook might have it like this. Let me just finish the diagram. Some of the textbook might have it like this. Whatever is in the textbook is still the same thing. So some of the textbook might have it like this. Okay? Like this. So this should be inside here. 1, 2, 3, blah, 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 blah. And then maybe something like this. Okay, whatever is in your textbook. Now, this is the main scale. This is the vernier scale. I'm going to tell you how to use this text now. Now, let's go through the questions. So the questions we have, the first question we're looking at, let's see 3 or 4 questions when we're off. Now, the first question we look at, let's say we have this diagram. We have this diagram, and then we have 1, 2, 3, 4. We have 1, a millimeter, and then we have 1, 2, 3, 4, 5. 1, 2, 3, 4. And then we have 2, a millimeter. We have 1, 2, 3, 4. We have 1, 2, 3, 4. Then we have 3, a millimeter. Then like that, and so on and so forth. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, now notice that this is how the question will look like. And then you are asked, what is the reading accuracy? I mean, this is a diagram given to you, and they say it's maybe a rod is being measured with a vernier caliper now. And the rod is being measured with a vernier caliper. What is the measurement of that rod? Alright, what's the measurement of that rod? The first thing to look for is to understand that this is called the main scale. This is called the main scale. Alright, now let's just put some calibration over here. So, alright, now this is called the vernier scale. Okay, this is called the vernier scale. Now, what you're going to find is that the main scale plus the vernier scale. Now, you need to look for what is called the point of coincidence. The point of coincidence is the point where the main scale and the vernier scale meet together. Now, look at this. If you open your eyes, I hope you can see. Now, if you watch this, the main scale is 1, and 1, 2, 3, 4, 1.5, 1, 2, 3, 4, 2, 2.1. The main scale is 2.1. Remember, in millimeter. Plus the vernier scale. The vernier scale, you count from here 1, 2, 3, 4, 5, 6, 7, 8, 9. The vernier scale is 9 because it has the point of coincidence. The point of coincidence is meeting. This is called the point of coincidence. So you look for the point of coincidence where the vernier scale and the main scale meet together, and that is actually 9. But meanwhile, it is a millimeter, so you are multiplying 9 by, look for the value of the reading accuracy of the vernier scale in millimeter. And if you go there, it is 0.1. So I'm multiplying 9 by 0.1. If I do that, this will become 2.1 millimeter plus 0.9. So I'm also in millimeter. Now, if I use my calculator, let me try out. So 2.1 plus, let's try it. Let's say 9, let's confirm this. 9 times 0.1. Yeah, 0.9, I'm correct. Plus 2.1. That is 3. Okay, this is 3 or 3.0 millimeter. You see? That's the final answer. That's how to solve it. It's a very, very quick forward question. Now let's solve another one. One more. Let's solve one more. Let's solve one more. So let's say we have something like this. We have something like this. We have something like this. Okay? We have something like this. 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2, 3, 4. We have 1 cm. 1, 2, 3, 4. 1, 2, 3, 4. 2 cm. 1, 2, 3, 4. 3. Sorry. 1, 2, 3, 4. 3 cm. Alright? And then the calibration on and off. Then we have this. And then we have this. Now, I intentionally drew this so that you can see that the point of coincidence is here. Now, what you're adding is the main scale plus the vernier scale. Now, look for the calibration, or you look for the options in the question. If the option is a millimeter, that means the reading accuracy they're going to use is a millimeter. If the option is a centimeter, the reading accuracy they're going to use is a centimeter. Or you look at the calibration on that main scale. Now, the calibration here is cm. I hope you can see that. That is cm. And this is also talking about the vernier caliber. So what do? Vernier caliber here, the main scale. This is the main scale. This is the vernier scale. And then the point of coincidence is here. This is PC. Point of coincidence. Alright? Now, check. This is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 2. Let's start from 2. 2.1, 2.2, 2.4, 2.5. So the main scale is 2.5 cm. And then we're adding it to the vernier scale. 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice that there is no other place this scale meets apart from this place. 1, 2, 3, 4, 5, 6, 7, 8. I don't want this one to meet, so let's take it away. I don't want it to, so you clear. 1, 2, 3, 4, 5, 6, 7, 8, 9. You see, it meets at 0.9, so we're adding by 9, but you're going to multiply that 9 with the reading accuracy of vernier caliber in cm. And in cm, that is 0.01. 0.01. Alright? Now, if you do this, this is 2.5 cm plus, this should be 0.09. Alright? In cm. And then, when you add that together, what would that mean? Let's add it together. 2.5 plus 0.09. That is going to give me 2.59 cm. So that's the final answer. 2.59 cm. So the next class, we're going to have a class where we have question, UTM question on this guy. So we'll solve problems on that UTM alone. But this is just a preview or to show you how it's been done. Now the last one is the micrometer screw gauge, and then we are off. Micrometer screw gauge, and then we are off. Now, I want you to look at this diagram. Look at this diagram. Just look at it. Look at this diagram. Alright? 1, 2, 3, 4. This is 1 cm. 1, 2, 3, 4. This is 2. 1, 2, 3. And then you have this. You have this 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. But this is what we have here. Right? This is what we have here. We have this. This is 5. 1, 2, 3, 4, 5. Okay? This is 5. 1, 2, 3, 4, 5. 6. Oh, 1, 2, 3, 4. 1, 2, 5. 1, 2, 3, 4. And there's 5. Let's call this 10. For instance, now, this is what we have. Okay, for instance. Now, you want to know, you know that this is the main scale. This is the vernier scale. Alright? Now, the main scale is 2. 1, 2, 3. 2.3, that's the main scale. 2.3. The vernier scale, watch. Don't be afraid, just watch. The main scale is 2.3. Where does the main scale and the vernier scale meet together? This is it, which is called point of coincidence. Alright? Now, this is 5, 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7. This is plus 5.7. You see that? And the accuracy is in cm. I mean, the graduation is in cm. Now, what is really the accuracy of microscope gauge in cm? The cm is 0.001, which means this is 2.3 plus 0.0057. Let's confirm that anyway. But that, I think that's what it should be. But let's confirm it. 0.001 times by 5.7. 0.0057. Correct. I'm correct. 0.0057. We're adding the 2.1, 2.3 plus 2.3. That will give me 2.3057 in cm. So that's the final answer. That's the final answer. So if you have watched this video till this point, this is what we got for you. In our next class, we'll show you other examples. And if you have a question, make sure you drop your question in the comment section. We'll be pleased to have your question and we're going to attend to it. Now, thank you very much for watching. See you soon. Bye.